Hello everyone, thank you for being here today. I am Junpal. We will learn and experience the creation of a 3D crystal model of sodium chloride. So what are you waiting for? Let's go and have some fun. Sodium chloride, commonly known as salt, is an ionic compound with the chemical formula NaCl, representing a 1-to-1 ratio of sodium and chloride ions, and it has a cubic unit cell, with molar masses of 22.99 and 35.45 grams per mole respectively. It is best thought of as a face-centered cubic crystal structure, which is the most common crystal structure. Atoms are arranged at the corners and center of each cube face of the cell. This structure is one of the most stable crystal structures and has the highest packing density. The cell looks the same whether you start with anions or cations on the corners. Each ion is 6 coordinated and has a local octahedral geometry. This picture shows how the Na or the sodium and Cl or the chloride ions occupy the space. The smaller ions are the chloride, which has an atomic radius of 102 picometers, and the larger ions are the chloride with an atomic radius of 181 picometers. Since sodium chloride are 1-to-1 ratio as a compound, the coordination numbers of Na and Cl are equal. The larger green ions represent Cl and the smaller purple ions represent Na. However, the structure of this molecule allows their position to be switched since the coordination numbers are equivalent. So these are the physiochemical properties of sodium chloride. So let's start with an appearance. Sodium chloride has an appearance of a colorless crystalline solid, has a molecular weight of 58.44 grams per mole, has a density of 2.17 grams per cubic centimeters, a melting point of 801 degrees Celsius, a boiling point of 1413 degrees Celsius, has a hardness Mohs scale is 2.0, and its compressive strength is 27.0 megapascal. Sodium chloride, commonly known as salt, is one of the most abundant minerals on Earth and an essential nutrient for many animals and plants. It is one of the most well-known and widely used chemicals. Sodium chloride is naturally found in seawater and in underground rock formations. So there are a lot of applications of sodium chloride. First, we'll tackle about medical and health. So hospitals use an intravenous sodium chloride solution to supply water and salt to patients to alleviate dehydration. Sodium chloride is essential to maintain the electrolyte balance of fluids in a person's body. If levels of electrolytes become too high or too low, a person can become dehydrated or over-dehydrated. Secondly, food and flavoring preservations. Sodium chloride has been used to flavor and preserve foods for thousands of years. As a preservative, salt helps to prevent spoilage and helps to keep food like ready-to-eat meats and cheeses safe to eat. Salt is also used in fermentation processes for foods. Thirdly, for the manufacturing aspect, large quantities of sodium chloride are used in industrial manufacturing settings to make a range of products: plastic, paper, rubber, glass, chlorine, polyester, household bleach, soaps, detergents, and dyes are used using sodium chloride. And lastly, the safety of NaCl. Salt, which is all we know as sodium chloride, is regulated by the US Food and Drug Administration or the FDA as a generally recognized as safe or GRAS ingredient. A GRAS substance is one that has a long history of safe, common use in foods or that is determined to be safe for the intended use based on proven science. FDA notes that consuming too much salt can contribute to high blood pressure or hypertension. Now let us move on to the creation of my very own 3D crystal model of sodium chloride. So the materials that I managed to salvage and recycle at my home are unused clays and straws. Through these materials, I can build and put to life the structure of sodium chloride. First, I form the clay into small circular balls to represent the atoms. I got a little bothered since it is difficult to mold them into perfect small balls. It is really fun to use clays as this takes me back to my past self where I created different shapes and objects, bringing them to life. The basis is two ions, a sodium cation and a chlorine anion. The pure green clay represents sodium cation and the green and orange clay represents the chlorine anion. I mix the green and orange to have a different color since all I have available and recycled from my old stacks of clay is mostly the green clay. The cell looks the same whether you start with anions or cations on the corners. I use a scissor to cut different parts of the straws in order to connect the clays. Then, I connect them using the straws, starting with the base and ending with the top portion. It actually took me a longer time to truly form the structure. I even needed aid from my friend to properly form and make the structure stand, since it kept falling off due to lack of support. It is very difficult to do it alone on my part. I also recommend using stronger straws and even using some type of adhesive to properly form the structure to prevent damage. But despite all the hardships, it was still a great learning experience in creating a 3D model and learning more about sodium chloride. There are many reasons why the study of crystal structure is important. Firstly, the overall performance of a material in regards to manufacturing and design is largely determined by its crystal structure. It determines the arrangement of atoms in a particular material, and it also signifies the bond lengths and the lattice parameter of a particular material. The atomic arrangement is responsible for the strength and ductility of the material. A great example is the difference between two minerals, which is graphite and diamond. This shows that it is not only important to know what elements are in the mineral, but it is also very important to know how those elements are stacked together. Patience and hard work must be initiated to fully tackle this project, and I finally finished it. I love the end result of my 3D crystal model of sodium chloride. Thank you for being with me on this journey of building my first 3D crystal model.